I'm going to talk about unlocking high frequency deployments. If you have used Prometheus or any metric system for long, series churn is a problem, and it has been a problem for many years. In this talk, we are going to spend most of the time looking at what's the problem, why does it happen, because the solution is simple in theory. A little about me. Joe already mentioned I'm a staff engineer at Reddit. I work on the observability team. We manage all the observability database at Reddit. I'm also a Prometheus team member. I maintain mainly its TSDB. I also worked on Mimir and Cortex in my previous job at Grafana Labs. Both of those are distributed time series database based out of Prometheus. So let's start with a little bit of basics. Since you chose to be in this talk, I'm confident that you know what Prometheus is and a few basics around it. So I'm going to go quickly over this. Prometheus is a metrics monitoring system. It has its own time series database in it, and it does alerting. It's a pull-based system. It scrapes all the metrics from your different targets and stuff around that. It's a single node, reliable metrics monitoring system. What I'm interested here is in the data model. In a metric system, a time series, it has an identifier and a bunch of timestamp and values. That's why it's a time series. And in Prometheus, the identifier is a bunch of label values. And the interesting thing here is a unique set of label values consists of a single time series. In this example, it's HTTP request total. So it's going to tell you the total request for that given job, for that given instance, for that given status. If I change a label, say status equals to 500, there is no correlation between these two time series. They are unique. This is important to understand the problem. This is how Prometheus works. Every series is unique in itself. It's flexible. You don't need to define any schema. You can add as many labels as you want, as many values that you want. And it's just the total number of these unique combinations you have active determines how many time series you have right now. And couple of terminologies. When I say active series, these are the time series that Prometheus is actively scraping from some target. It's getting more timestamp, more values as the time goes. Stale series are the ones that were active at some point of time. It was getting some data, but something happened and the target is away, or there are many reasons a series goes stale. It stops getting any form of data. So let's see what are the causes of these stale series that I'm talking about and what problem does it cause. A couple of very simple ways the series can go stale is a target. It's just a process. A process goes down, you no longer need it. So all the metrics that are exposed by that process is now stale. It's no longer getting data. Or you decided to add an additional label to your metrics. It's not going to modify the existing time series. When you deploy these new labels, the old series goes stale. They're not getting any data. And you added new labels. It's new time series technically for Prometheus. So that's how series goes stale. But one subtle way the series goes stale is rollout. You're running a software, you're developing it continuously. So you're obviously going to roll it out multiple times. I'm going to take an example of Kubernetes deployment and stateful set. In Kubernetes deployment, it's a stateless pod. More than likely, you are going to have the pod label attached to the metrics. Every time you roll out, for example, the pod name changes. So all the metrics attached to that pod gets a new label. So the old one goes stale and you have a new set of metrics. And in stateful set, it's a choice, I would say. At Reddit, we attach the instance label, which means every time you roll out or restart a stateful pod, although the pod name remains same, the IP will likely change, in which case all the time series related to that pod is going to come up new. So it's like let's say you have 100 metrics for a single pod, you restart the pod, you have new 100 metrics. So Prometheus is storing 200 metrics in the memory right now. To visualize how it looks like, the head is the in-memory part of the Prometheus TSDB, and all the different color boxes are individual time series here. And on the disk, you have the write-ahead log. There is a block format, which is just a dump of the in-memory data to query. And as and when the time goes, and this box assume it's the limit of how much you can store in the head, because that's the limit of the memory. If you try to store anything beyond the box, it's going to crash with out of memory error. And time series can start at any point of time, it can end at any point of time. The two cross marks that I did are the series that stopped getting data, it became stale, and over time you will just collect a lot of stale series. In this example, I have like 12 time series, 6 of them went stale. And Prometheus flushes this in-memory data to disk every 2 hours. So if you are holding on to all these stale series in the memory, it's possible you are going to run out of space in the memory. And we'll look at a practical example how this looks like. So these are actual data from the systems that we're running. I created the slides too late, so I didn't have time to take approval on the screenshots to include it in the slides. So I have normalized the memory request here. The top chart is the memory used by the Prometheus pod. This bottom left panel is the stale series ratio, which is basically the percentage of time series that are stale in Prometheus right now. And this is the total series. I have normalized all the values. We'll go over 4 phases in this diagram. First one is the blue arrow mark that you see on all the charts. The memory suddenly increased, and the reason is not because suddenly there are more time series. If you look at the bottom 2 charts, the stale series ratio suddenly went up. So there are like 70% of series that are not active anymore, because suddenly someone decided to roll out something quickly. A lot of series went stale, and only a few set of series that are actually getting data. But Prometheus holds on to everything in the memory for some time. But luckily, after some time, the timely flush of Prometheus happened. The memory went down, the stale series went down, and the total series went down. Good. But next time, they decided to do even more rollouts in a short period of time. So instead of the series growing up to here to the previous level, it jumped more. The stale series ratio kind of remained flat, but that's just the ratio, right? The total number of series grew. So the memory also grew over time. And over time, it did not get to the usual timely compaction of Prometheus to flush the data to disk. So it eventually went out of memory. And this was a simple example where there were like 2 or 3 rollouts, but it ultimately puts a cap on how many rollouts you can do, because at the end of the day, you are going to run out of the node size. Even if you give a 1 terabyte memory of Prometheus, but you have thousands of pods, it will put a limit on how many times you can roll out within an hour or within 2 hours, because it's just going to blow away Prometheus, and alerting is important. You can shard Prometheus in multiple, like run 10 Prometheus with subset of targets, but that brings whole sort of different challenges to have data distributed among multiple Prometheus. So the goal here is how can we solve it within Prometheus? Yeah, the memory happened there. And one interesting thing to note here is the gap between the total number of series and total number, the stale series, is what is actually getting the data. I use the same size for these 4 arrow marks, and you can see that at any point of time, the active series is actually pretty consistently same. So if we didn't have so many stale series in the memory, we probably wouldn't crash Prometheus, and the alerting would be stable. The solution, it's actually what you think. As I said, it's simple in theory. Why are you keeping all the stale series in memory until the next compaction? Why not just do stale series compaction and put it in block on disk? So this was not done till now because there are a lot of optimizations that are there in the TSDB to make the the happy path work very efficiently. When you're trying to take series out of band and put it on disk, you have to do a lot of risky bets, like it should not crash TSDB. So just because of the risk, it had not been done, but with Prometheus being adopted for big instances, it was needed now. So it's simple in theory. You take the stale series and put it on disk, but as it's practically a little complicated, it's an experimental feature and it has a known bug. It was just released last month. It has a known bug. So it's not for using in production right now, but it will be soon. So let's see how would you actually configure this and see it in action that it really works? It's good in theory, but it should also work, and what are the trade-offs? The configuration is simple. The stale series ratio, which is the percentage of stale series that are in the TSDB, is going to be between 0 and 1. So you decide, when do you want to trigger this stale series compaction? Is it when stale series hits 50%, 20%, or 75%? That's just the config, but it's not straightforward to choose one number for this. I'll give an example of real world where it worked. So in this example, the stale series ratio, I chose 0.4. I'll come to it later how I chose 0.4. The blue line, which is indicated by new, is the one that where the stale series compaction was enabled. This is the point, the red arrow mark is the point where the stale series compaction took place. The stale series ratio had gone beyond 0.4. There are other small things that TSDB has to take care, so the compaction was not immediate. But as soon as the stale series compaction hit, the stale series ratio went down, the total series went down, and the memory usage went down. The important part here is not using less memory, it's hitting lower peak memory. This is just one example where the peak memory hit roughly 20 to 30% higher without stale series compaction. So if your memory limit was somewhere here, maybe it would crash. And if there were more rollouts during this period, it's very likely with stale series compaction, the memory will remain flat here, because as soon as you get more stale series, it flushes it down to disk, but without stale series, it can keep growing up. But it's not free, because you saw the memory going down, but on the other side, whenever the stale series compaction happens, the CPU can go up. It's not like it will always go up, but the CPU can go up. In here, it was like up to 40% more CPU at certain point. Even if it does go up, sometimes it's not a problem, because if you want Prometheus to run efficiently for queries and scraping at high, big scale, you will most likely have some headroom in the CPU, because without headroom, things can go pretty inefficient because of how Linux schedules your processor. So why does it take more CPU? So before stale series compaction, when all the data is in the memory, when you are running a lot of recording rules are something which just runs in the background, some queries, and stores the result of that. It's like materialized views. More often than not, like almost always, your recording rules are touching recent data. The old data is on the disk, the recent data is on the memory. So when the stale series compaction is not enabled, it has to read everything from memory. It's simple. But when you compact the stale series, put it on disk, it now has to load the data from the memory, load from the disk, but the expensive part is merging them and running queries on that. So there is more CPU usage if you have a lot of rules running. If you don't have a lot of rules, then probably it's not a lot of overhead, and you can avoid the peak memory usage. It is very hit and trial how you choose the stale series ratio. It depends on your rule load, how much you want to trade off with CPU, and how much is the size of your Prometheus in the first place. If you can go bigger, maybe it's better to go bigger in Prometheus. But this feature is only to protect your Prometheus and not to save memory, because we saw that it comes with a trade-off. So you should use this only if you are about to blow up your Prometheus. And there are two metrics from version 3.6 onwards. You can run this PromQL to see what is the ratio. And these are just some guidelines. The slides will be available later if you want to just go through this table. Because I have very less time, I'm going to go through next two slides. In the real world example that I showed earlier, where it worked well, this was the stale series ratio. It was always above 0.4, and a lot of times touched 0.6 and 0.7. So I just took a judgment call, let's try 0.4, because I'll show one more slide where the lower number didn't work well. But it's possible. 0.5 could have worked better, 0.3 could have worked better. But you need to plot the stale series ratio, see where your peak is, say where the bottom is, and maybe somewhere along the midline is what you want to use. There is a problem with choosing too small of a stale series ratio. In this case, the orange line is the original one, and after compaction, with the blue line is the one where SteelSeries compaction was enabled. Because the Prometheus was small, the SteelSeries peaked at around 0.3. There was not enough SteelSeries. The overhead of running SteelSeries compaction and running queries on top of that was more, like the memory usage was more, so CPU usage was more. So if there are not enough SteelSeries and you choose to enable this with a lower threshold for SteelSeries compaction, it's going to perform worse. So I would like to end the talk with, like, try this out, help to mature this feature, tell us your experience of how you went about choosing your SteelSeries ratio, like what kind of config you use, because it can vary based on workload. The same config is not going to work in every case. And you can give feedback in Prometheus or Prometheus dev channels in CNCF Slack. And I mentioned there is a bug fix, so that's why you should not use in production right now, but you can try it out. So hopefully in the next 2 releases, the bug will be fixed. And thank you. I guess I'm over time.